All right, this is 4-2 on exponents, expressions with exponents. So we just stated that, how do you say this expression? Isabella?
3 to the 4th power.
3 to the 4th power. And this means 3 times 3 times 3 times 3. Now when I'm doing this, I generally, to simplify my math, I will, what I will do, instead of doing 3 times 3 is 9, times 3 is 27, 27 times 3, I don't know that in my head. So what I do is I simplify it, and I say 3 times 3 is 9, and this 3 times 3 is 9, and 9 times 9 is 81, and that's how I make it simpler for myself. But, now what do we call the parts? What are we calling these parts? Anybody? What do we call the parts of this portion right in here? Okay, yes.
Exponential notation.
Okay, we could say it's exponential notation, but what's the little 4 called? Yes?
It's called the exponent, and the 3 is called the base.
The 4 is the exponent, and the 3 is the base. Now that is key here, because as complicated as these get, I'm going to always ask that question. What is the base of that exponent? What is the base of that exponent? Okay, so we have 3 to the 4th power. So let's try it. Now, you guys stated that it's repeated multiplication. I heard that. Times itself. That many of times. I kept hearing all these words out of you. You said it was a big number with a little number in the upper right corner. All of that was correct. So how would I go about it? It says rewrite each power as repeated multiplication. Let's start that first. How would I show 5 to the 2nd power as repeated multiplication? Josh?
5 times 5.
5 times 5, because the exponent says twice. That means I repeat it twice. 5 times itself. And then it says and evaluate. So there's 2 parts to this. Rewrite each as repeated multiplication. That's here. And now it says evaluate. And that means find the value. Okay? Finding the value. We don't solve expressions. We evaluate them. We find the value of them. So 5 squared is 25. Okay? I'd like you to do that for 2 through 4. Stop the recording and do the work. Okay, so 2 to the 4th power equals 2 times 2 times 2 times 2. Keep going.
So I first multiplied the first 2 2's, so 2 times 2 is 4.
Okay.
And then the other one is also 4. So it'd be 4 times 4, and that equals 16.
Okay, and that equals 16. Good. Okay, next one. Chris. Number 3.
For number 3 plus 10, to the power of 3 is 2. So I did 10 times 10.
And what does it evaluate to?
110.
What?
1,000.
1,000 what?
10.
No, just 1,000.
Oh.
Okay? Notice the shortcut here. Only with powers of 10. 10 to the 3rd. There's 3 zeros. 10 to the 4th. 4 zeros. Okay? Number 4, please. How about Hillary?
Okay, so 12 times 2 equals 12 times 12. 12 times 12 equals 144.
144. Now notice I just keep writing my equal signs, and we're good. Moving on. Okay, the big part to know here is the base. What is the base and what is the exponent? I'm going to skip this. All right, so now let's talk about how to speak the math. How would I say this? Eva. 7 to the power of 2. Is there another way to say it? Not Zach, Nick. 7 squared. Okay. Next one. And this means 7 times 7. Next one. How do I say this? William?
5 cubed.
5 cubed or?
5 to the third power.
5 to the third power. And what does that mean, Sergio?
5 times 5 times 5.
5 times 5 times 5. Okay. Next one. Somebody that hasn't answered a question? Ava.
9 to the 4th power.
Right, 9 to the 4th power. Does this have another way to say it?
No.
No, just 9 to the 4th power. The only ones that have additional ways of saying them is cubing and squaring.
That would be 9.
Is what? No. Okay, go on. Okay, guys, I'm recording. Go on.
9, 9, 9.
What's 9999?
9 times 9 times 9.
That's right. 9 times 9 times 9 times 9. If you don't put the sign there or say it, it doesn't mean it. All right. Next one. Let's go with Olivia in the back.
2 to the 5th power.
Which is?
2 times 2 times 2 times 2.
Good. So that's how we speak the exponents. All right, so now let's talk about where we use some of these. Perimeter, area, and volume. Okay, let's look at perimeter. When I'm looking for the perimeter of a square, I basically count the sides up, and I get side plus side plus side plus side. And whatever those sides are, 5 plus 5 plus 5 plus 5, I get 20 units. Because I'm adding all the units up. Okay? It's 20 units. But when I'm doing the area of a square, look what I'm doing. I'm doing the 5 units. How do we find area of a rectangle or a square? Yes. Length times width. What about area of a square? Side times side, right? I'm multiplying 5 units times 5 units. Here, where I'm doing 5 units plus 5 units plus 5 units plus 5 units. Oops. Right here, I'm doing 5 units times 5 units. 5 times 5 is 25, and units times units makes units squared. Square units. You understanding why they say area is always squared? Because I'm multiplying the dimension over there times the dimension over here. Now volume. Can I erase this?
No.
Okay. Are you done, Tati? Because you're talking. Okay, now volume. Can I erase? Look what happens with volume. So I've got five units. 5 units, that's the length and the width, right? And now the height is also 5 units. So here I'm doing 5 units times 5 units times another 5 units. Okay? So units times units times units makes units cubed. And 5 times 5 times 5 is 125. Do you understand where area and volume, why we square them? Am I multiplying the units in perimeter? Are we multiplying them? Units times units? No. I might multiply 4 times 5 units, but not. So we have our units here to the first power. Can I erase? Okay, I'm erasing here. Okay. All right. So with perimeter, it's one dimension, meaning we're only adding up one dimension. Area is always two dimensions because I'm multiplying two dimensions, length by width. And volume is three-dimensional because we are multiplying length by width by height. Okay, and we use our exponents to explain that. All right, so the first part of tonight's homework is evaluating. Evaluate, they won't say simplify, they'll probably say evaluate when x equals 4. That means we write the original problem. You don't just leave it in your book, you must write the original problem. Step 2, you substitute in. And step 3, you evaluate it. So 4 squared is, which is 16. Okay, I'd like for you to do 2 through 6. Go, pause the recording now and evaluate the expressions. Oh my gosh. Shh. Stop screaming out. Excuse me. All right, so Sarah, what is the answer? No, I have not heard the right answer yet. Sydney. Thank you. Shh. All right. I'm going to... That means this many people did not do their double-digit multiplication right. I'm going to say that by the end of this year, when we get to perfect squares and Pythagorean theorem, shh, I need the commentary to stop. When we get to perfect squares, I'm going to expect that you have that memorized, your perfect squares through 17, through 20. So that shouldn't be an issue next year when that comes up. Okay, next one. What do we have here? Sergio?
Okay, so you have 10 to the 4th power.
10 to the 4th power. And what does that equal?
10 times 10 times 10 times 10.
And that ends up being?
Is it 1 million? 10,000.
How many zeros?
10,000. 10,000.
Shh. First of all, when you have powers of 10, this only works with powers of 10. This means you're going to have 1, 2, 3, 4 zeros when you see that. So instead of expanding it all out, you can just write your 4 zeros.
Oh, that's smart.
Okay? So, it is 10,000.
I didn't phrase it right, but I got the right answer.
Okay, next. 1. 2 to the x power. Josh, what did you get? What do I do?
You rewrite it, and it would be 2 times 2 times 2 times 2.
Wait, first, before I do that, I have to rewrite it. I have to substitute in. Equals what?
2 to the 4th power.
And that equals?
2 times 2 times 2 times 2.
Okay, and that ends up being?
16.
16. Next one. What do I do first? Lilith.
You put in the 4.
We substitute in the 4s. 4 squared times 4. And what is it?
4 times 4 times 4.
And that equals?
64.
Good. Okay. And last but not least, I substitute in. It's 4 to the first power. That just means 4. Okay. Questions? All right. Let's look at, again, powers of 10. What are we doing? What's the easy shortcut to get there? William. Shh.
That's how many zeros are.
Right, so I just do 1 plus 3 zeros. Paulina, what about number 2? 1 with how many zeros?
5.
Good. 1, 2, 3, 4, 5. And then I place my commas so I can read it properly. Jeremy.
Wait, number 3.
Yep.
8 zeros.
1 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then I place my... Okay. Oh, yeah, I did boo-boo it. 1, 2, 3. So it's 100 million. All right. Shh. If I'm doing 7, okay, this is easy. Just evaluate your exponent first. 1 to the third, 10 to the third power is really
1,000.
1,000 times 7.
7,000.
Right. Okay. Now look. Another way to look at it is 8 times 5 zeros. 4, 5. And we get 80,000. Another thing I can do is count 1, 2, 3, 4, 5 places. Right? Move it over 5 places. I can do the same thing here. Shh. When I have a decimal, move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Place my decimal and fill the rest with zeros. Am I placing 8 zeros on this one this time? No, because one of those places I'm multiplying by is moving it past the 7. Did you guys get that?
Yes.
Sophia, did you understand that?
Oh, yeah.
Okay. All right. So now let's move on to the nitty-gritty of the homework. Shh. And this, I'm not asking again. I do not feel well today. Can you please stop having these secondary conversations? Okay. This is very important. This is what gets my algebra students right here. Number 1 and 2. Okay? Number 1, 2, and 6. Actually, this whole page. So let's talk about, remember what I said to you. Every time you do an exponent, you work with an exponent, you always have to ask yourself, what is the base of that exponent? So right here on number 1, what is the base of the exponent? Paulina. Okay, let me rephrase that. The base of the exponent is what the exponent touches. So what is the exponent touching, Paulina? What is it closest to? The parenthesis. So everything inside of the parenthesis is part of that exponent because it touches the parenthesis. That means everything in there is to the 4th power. So this really means, right here it is, -7 times -7 times -7 times -7. That exponent has to do with everything in that parenthesis because it touches the parenthesis. Now in number 2, Henry, what is the base of that exponent? Be careful, what is it touching? Remember the question is, what is the base? What is it touching? Only the 7. The negative is not part of that exponent. So this really means negative 7, and only the 7 is repeated 4 times. Did you get that?
Yes.
So this answer, number 2, will end up being negative or positive?
Negative.
That's going to be a negative. And if we're doing 49 times 49, they're not really asking you to evaluate it. They're asking you to write the following without using. So 49. Okay, so the value of this one is negative 2401. But the value of the top one, what is it? 2401, and it's positive. Because negative times negative makes a positive. And this negative times negative makes a positive, and a positive times a positive. Do you understand? This is the problem between a right answer and a wrong answer. This is the problem between a failing algebra student and a passing algebra student. And those of you that are having small little sidebar conversations and are not paying attention to this are going to have a hard time in algebra. You got that, Paris? Okay, so just make sure that you are hearing this. Are you understanding? Because I see you working, and I'm worried that you're not going to get this very slight rule. It's not like the kind of rule that's really out there. This is going to come up when you're working really quickly. And seriously, my algebra students, it's the difference between them being an A semester, first semester, and dropping down to a D. Because they don't know what the base of that exponent is. In number 1, the base of the exponent is the parenthesis. Everything in there. That gets repeated 4 times. In number 2, what is the base of the exponent? 7 only. Do you understand? It's very small, minute detail. Henry, straight A student. I barely have to teach anything. Barely have to teach anything to this kid. But this is the kind of detail that you're going to be in here for. Because this is the kind of detail that really kids in algebra drop second semester because of this. Okay? I really don't have to teach for Henry. He knows it all. Okay, so why don't you guys try the next 3. Go. Tell me the meaning. Number 6 is a little different. You can try it. So pause the recording and you guys continue. Practice. All right. I forgot to. Okay, so again, number 3, what's touching the parentheses is 5y. What's touching the exponent is the parentheses, so everything inside. Number 3 is repeated. Number 4, only the y is touching the exponent, so we only repeat that y. Number 5, it's the entire parenthesis, so the whole thing gets repeated. And number 6, the parenthesis gets repeated, so it's x plus 8 times the quantity of x plus 8. Please do not distribute an exponent. We don't pass an exponent out inside over a plus sign. Okay? All right. I'm going to go through this really quick. Anything to the 0 power, do you know what that equals? 1. And I will explain that in another couple lessons. But anything to the 0 power will always equal 1. If it is to the first power, it equals itself. But anything to the 0 power always equals 1. But let's look at evaluating. So in this situation, this is what you're going to be doing a lot of tonight. Step 1, write the problem. Step 2, substitute. D, is 5. A is 2. What gets squared here? 2 only. Simplify right underneath 5. And 2 to the 4th is 16. And so we get negative 11. Why don't you guys try number 2? Go. All right, so what am I doing? Step 1. How about Michaela?
Substituting the variables.
So how's it going to read?
So A gets to like gets 2.
2 what?
2 squared
Minus.
minus 3 squared.
Perfect.
And then do the variables. So
Now we use our order of operations.
So you do exponents. So 2 times 2
Is
is 4.
and 3 squared is.
9.
So 4 minus 9 is.
Negative 5.
There we go. Questions. Let's jump down to number 5. Wait. Shh. What am I doing first in my order of operations for number 5? Right here. Shh. Nobody's dismissed. Okay, Eva. Multiply, then exponent. We do the group inside. 2 times 3 is 6, and 6 squared is 36. All right, and that's the lesson for today. 4-2.